Hello everyone, welcome to the Digital Electronics class. In this presentation, we will discuss the SR latch. We have already studied that the only difference between the sequential circuit and the combinational circuit is the memory element. In sequential circuit, we have the memory element and it is used for storing the past output. So, we want to store a single bit number here, that is we want to store either a 0 or a 1. So, in order to store a 0 or a 1, that is a single bit number, we use a circuit which is called a latch. So, we can say that the basic storage element is called latch. It is called latch because it latches a 0 or a 1. In this presentation, we will study SR latch. The SR latch can be constructed either by using NOR gates or by using NAND gates. First we will consider the SR NOR latch. So this is the circuit of the SR NOR latch. Here we find that there are two NOR gates and the output of the first NOR gate is input to the second NOR gate. Similarly, the output of the second NOR gate is input to the first NOR gate. In this circuit, if we change the value of the inputs S and R, then the stored data will get changed, as a result of which the outputs will get changed. Now this R and S can change accidentally or intentionally because we are using this circuit along with different circuits, and if R and S is connected to some output, then if that output changes, then the value of R and S will also change, as a result of which the stored data will get removed. This is a disadvantage with this circuit, and we can overcome this disadvantage by using a clock. So the clock is used for controlling the stored value. Here the term R, that is this input R, stands for the reset input and the input S stands for the set input. Now in electronics, when we say set, it means that the output Q will be equal to 0. That is, we have resetted our circuit, and in that case the output Q will be equal to 0. And if we say set, then it means that the output Q will be equal to 1. So if S input is equal to 1, then it means that the output will be equal to 1, and similarly if the reset input is equal to 1, then it will make the Q output equal to 0. Now we have drawn the truth table of the NOR gates, which we will use in our analysis of the SR NOR latch. Now let us consider the different cases, that is, let us analyze this circuit for the different values of the inputs S and R. And let us find the value of the outputs Q and Q bar in each case. Let us consider the case when the value of R is equal to 1. So when the value of R is equal to 1, then this will definitely reset this circuit, and so it will make the value of the output Q equal to 0. Because we have already explained that when R is equal to 1, then it will make the value of Q equal to 0. So let us analyze this condition. So we have considered the first case, that when the value of the input S is 0 and R is equal to 1, then in that case the output will be equal to 0 because R is 1, so the output Q will be equal to 0 and its complement Q bar will be equal to 1. Now we want to store the data in this circuit, that is in the SR latch. When we use the word storing, it means that even if we remove the inputs R is equal to 1 and S is equal to 0, then this data must be stored in this circuit. That is, this output must not change and it must remain the same, that is 0, 1. That is, the value of Q should remain 0 and the value of Q bar should remain 1. Let us check whether this circuit works like this or not. So for this, we will remove the inputs from this circuit, that is, we will remove the inputs S and R, that is, we will make them equal to 0. And now again we will find out what are the values of Q and Q bar. So we have made the value of S is equal to 0, R is equal to 0. Now we will find out what are the values of the output Q and Q bar. Now let us come to this circuit. Here we find that the value of Q bar is 1. So this output is input to this NOR gate, and this is 0, this is 1. So 0, 1, 0, 1 will give 0. So we will get Q equal to 0. Now this output is input to this NOR gate. The value of this input is 0. So 0 and 0 will give 1. So we can see clearly here that we have stored the previous data in this case. That is, again we are getting the output Q as 0 and 1. Because even when we have removed the inputs S and R, that is, we have made them 0, still we are getting the outputs as 0 and 1, which is the same as in the previous case. For this reason we say that a flip-flop has memory. So this condition, that is S is equal to 0, R is equal to 0, in this case we will get the memory, that is whatever the value stored in the previous case, we will get the same thing in this case. So in this case we will get the memory, because the output of the stored data remains the same. So when S is equal to 0 and R is equal to 0, then we have the memory, that is we have the previous output. Now let us move on to the second case. In this case we will make the value of S is equal to 1 and R is equal to 0, and we will find out the values of Q and Q bar. We will do the analysis for the second case also. If any input is 1, then we don't need to see the other input, because the output is going to be 0, because in case of NOR gate, whenever any one input is equal to 1, then the output is going to be 0. So in this case the value of Q bar will be equal to 0, because the value of S is 1, so Q will be equal to 1 and Q bar will be equal to 0. Now let us remove this input, then this data must be stored in this circuit. So even when we remove these two inputs, that is we make them equal to 0, then the output should remain the same. So let us analyze for this case, that is when S is equal to 0, R is equal to 0, and we find that this value will be equal to 1. Now this 1 is input to this NOR gate, so 0, 1 will again give 0. Now this 0 and 0 will again give 1. So we find that even when we have removed this inputs S and R, that is we have made them 0, we are getting the same output in this case also, that is we are getting the memory. That is, even when S is 0, R is 0, in this case again we are getting the previous value, that is we are getting the memory. So these are two very important cases in the SR latch using NOR gates, but there is still one more case which is very important. So let us now move to the third case, that is when the value of S and R both are equal to 1, and let us find out the output in this case. If we substitute the value of S and R is equal to 1 in this case, we find that in case of NOR gate, even if any one of the input is 1, then the output will be equal to 0. So we find that in this case the value of the output Q will be equal to 0 and Q bar will also be equal to 0, as we have written here. When S is 1 and R is 1, then we will get the value of the outputs as Q is equal to 0 and Q bar is equal to 0. Now this is a contradiction, because this cannot be, both the outputs cannot be the same, because Q and Q bar are complement of each other. Now this is not the only case. Let us see whether this value remains the same even after removing the inputs. So if we remove the inputs, then the value of S will be 0 and R will be equal to 0. So we have removed the inputs, that is we have made them equal to 0. Now let Q1 will be equal to 0. Then in this case 0 and 0 will give 1. Similarly 1 and 0, 1 and 0 will again give 0. So in this case we find that when S is 0 and R is 0, we are getting Q is equal to 0 and Q bar is equal to 1. Because in this case we have considered that Q is equal to 0. If we consider Q equal to 0, then 0 0 will give 1. Now if we consider the value of Q bar is equal to 0, then in that case the value of Q will be equal to 1. So we find that even for the same input we are getting different outputs. So this case is not used because the configuration is such that it is not giving the correct result. So this cannot be true because Q and Q bar are complement of each other, and for the same input we cannot get the outputs, different outputs. So there is something wrong about this configuration, and so this case is not used. Now let us see what is the truth table of this SR NOR latch. So we have used all these cases to draw the truth table of this NOR latch. So we find that when the value of S and R is 0, then we will get the outputs the same as the previous value. If the value of S is 0 and R is 1, then we will get the value of Q is equal to 0 and Q bar is equal to 1, because whenever the reset value is 1, then the output will be 0. Similarly, when the set input is 1, we will get the output Q as 1 and its complement will be equal to 0. And we have also seen that when the value of the inputs S and R is 1, then this does not give the correct result. So this case is not used. Similarly, we can use an SR NOR latch, and by similar analysis we can draw the truth table of the NAND latch. But in this case we will find that when the value of the input S and R is 0, then it is the not used state. When the value of S is 0, we will get the value of Q as 1 and its complement will be 0. Similarly, when the value of S is 1 and R is 0, we will get the output as 0 1. When the inputs S is 0 and R is 1, we will get the output as 1 and 0. And when both the inputs are equal to 1, then we will get the memory, that is we will get the previous value. The only difference between this circuit and this circuit is that this is the reset input and this is the set input, but in case of NAND gate it is just the opposite. This is the set input and this is the reset input. So this is all for the SR latch. Hope everything is clear to you. See you in the next presentation.